GM has just announced their all-new zero-emission engine that will make electric and internal combustion vehicles obsolete. This all-new radical technology is said to be the next revolution in the automotive world and will drive us towards a completely eco-friendly future of cars. So, let's not waste any time and check out this new way of thinking as GM's CEO announces this new engine that will change the world. What exactly is this all-new technology? GM has been searching for an alternative to EVs for years now, and their search has led them to the all-new compressed air technology. Compressed air has already been seen to be of limited use in the 19th century, mostly with mine locomotives and trams in some European cities, the most notable of which is Paris. However, the technology has since been dropped and forgotten in favor of internal combustion engines because of their immediate potency. However, in the early 2010s, the French car manufacturer Peugeot saw the potential in combining compressed air with internal combustion engines into an all-new hybrid technology that retains the eco-friendliness of a regular hybrid without needing a battery. While these prototypes didn't move far from the testing stage, they did spark a fair bit of interest from the rest of the automotive industry, most notably GM. GM saw the potential that compressed air vehicles harnessed. However, they also realized that such a technology needed a fair bit of development if it were to compete with regular internal combustion engines and the rise of EVs. As a result, GM started slowly researching and developing compressed air technology parallel to developing EVs and internal combustion vehicles. So, with that in mind, it's high time for us to tackle a very practical question, and that is, how do compressed air vehicles function? Compressed air vehicles function very differently from regular engines and EVs. You see, instead of having a conventional piston-driven engine or an electric motor, compressed air vehicles utilize specially designed pneumatic engines, also known as compressed air engines. These engines are, from a mechanical standpoint, very similar to regular internal combustion engines. The engine uses pistons, just like petrol-powered ones do. However, unlike combustion engines, the pistons of a pneumatic motor are connected to a spring, and instead of relying on an explosion that creates the piston motion, pneumatic motors introduce air into the chamber, increasing the pressure inside of it, which pushes the piston to its maximum length. The air is then released, and the spring that the piston is attached to pulls it back into its original position, thus completing the cycle. Generally speaking, the engine is very similar to internal combustion engines and can therefore use a wide array of technical solutions, shortening the development cycle, which is what also drew GM towards this concept. With that in mind, it's time to answer the most intriguing question. What are the benefits of compressed air against EVs and ICE vehicles? Well, the most notable benefit is, of course, the fact that it is 100% pollution-free. It's just pressured-up air, meaning that there is no environmental damage being done while it functions. As a result, compressed air engines solve one of the biggest issues regular combustion engines have, and that is direct pollution of the environment. Compressed air engines also beat out EVs in this regard, as making a compressed air engine is far cheaper and requires no rare earth materials, much unlike batteries or electric motors. Not to mention that powering EVs is also not quite green, as the grid is still mostly reliant on fossil fuels to produce electricity. Speaking of making compressed air engines, another key benefit over internal combustion engines is the cost of production. Since compressed air engines endure considerably lower pressures than gasoline or diesel engines, producing them means that there will be a lesser need for strong and hardened steel or metal. This makes them both more economically viable as well as more eco-friendly to produce in larger quantities. And while the differences might not be as substantial as compared to EVs, they're still there. Oh, and also it goes without saying that the running costs of compressed air engines are simply unrivaled. Compressed air is much cheaper than fuel or electricity, and it's also much easier to acquire. Not to mention that these engines will be 100% future-proof, as they don't waste anything. They just use pressurized air that, after it exits the chamber, remains structurally unchanged. However, as potent as they sound, compressed air engines have a few drawbacks that keep them from being developed and used on a wider scale. Are there any drawbacks to this technology? Unfortunately, there are a few glaring issues that arise from using compressed air engines, which made them quite situational and even borderline useless in the past. The first problem is the fact that compressed air engines are extremely underpowered. Pressurized air has a very low energy density, which considerably lowers its potency. Plus, due to them having light components and them not producing high amounts of pressure, the torque of such engines is extremely lackluster, which makes them much less usable in the real world. The engine also has to spin at quite high RPM, which, considering it's a fully mechanical contraption, leads to excessive wearing of components. And if that wasn't enough, since the engine does not utilize liquid as its main propellant, introducing lubricators into the engine isn't as easy as on internal combustion engines. However, the biggest issue that compressed air engines face is the fact that they are extremely inefficient. And while this might sound inessential, seeing how compressed air is virtually free, this couldn't be further from the truth. Most prototype compressed air vehicles that have been developed have a range of only 140 kilometers, which is less than 100 miles. This means that first of all, you would have to fill it up constantly, and second of all, you couldn't reliably go on a moderately long trip, let alone a long one. Finally, there's the question of safety. Most prototypes used regular steel air tanks for storing pressurized air due to a lack of a better solution. This meant that the car, which was already gutless in itself, would be prominently less potent due to increased weight, while also being susceptible to explosions if the tanks were damaged, as you were, after all, sitting on a bunch of pressurized gas. That said, GM has been working extremely hard on ridding this technology of its glaring issues, and they have been quite successful at it. First of all, the problem of the car's power has been solved with the introduction of new high-pressure air tanks. These high-pressure tanks compress the air even further, which translates into higher cylinder pressure. As a result, GM's new compressed air prototype achieves performance figures that are pretty comparable to regular gasoline engines. Sure, the torque isn't quite there yet. However, they're still powerful enough for a normal commuter vehicle. Furthermore, GM has also found a way to extend the vehicle's range. How? Well, by turning the vehicle's chassis into one large compressed air reservoir. However, this requires the vehicle to be specifically developed with compressed air engines in mind. This includes specific reinforcements or even the usage of composite materials such as fiber-reinforced thermoplastics. This allows the vehicle to retain exceptionally low weight while also being much safer than using regular high-pressure tanks, as crashing and rupturing the reservoir won't lead to an explosion, no matter what. When will this technology be implemented? Well, the answer to that question is incredibly complex. However, there is a very solid possibility of these engines entering mass production in the next few years. This is because, as can be concluded, GM has truly invested itself in making this engine a reality. They keep researching and developing solutions to many existing problems and are incredibly devoted to creating a truly fantastic product that would revolutionize the automotive world entirely. Plus, the general mechanical familiarity and similarity to internal combustion engines allow GM to develop such engines much faster than if they were doing it from scratch. That said, it would be naive of us to believe that GM is doing this out of the goodness of its heart, as it is not. GM understands all too well that the days of internal combustion engines are numbered, and they still don't have a foothold in the EV market. As a result, GM is looking for a way to create a new market of vehicles that would allow them to dominate other car manufacturers while also making obsolete both internal combustion and EVs to further secure their hypothetical position as the leader of the new automotive age. But as good as this all sounds, this isn't the first time a major manufacturer tried implementing compressed air into vehicles. As we've already mentioned, Peugeot, 10 or so years ago, made a hybrid version of their Peugeot 2008 crossover. However, instead of using electric energy, this vehicle combined an internal combustion engine with compressed air. The result was a powertrain that merged the power and torque of an internal combustion engine with the ecological component of compressed air engines. The said powertrain was able to achieve a whopping 120 miles per gallon. Unfortunately, though, Peugeot silently abandoned this project soon after it was conceived, despite the very good initial results. There were no explanations given, except that Peugeot said they didn't find the project profitable enough, which frankly doesn't make sense. So, why did they abandon it? It's anyone's guess. Thanks for watching this video.